source tree. And the second is from Git Bucket, which are two standalone softwares used with Git. The purpose of this thesis was to find a better way to portray the visualization of development history. Because people are having difficulties in learning and understanding Git. So information visualization in 2D and 3D also has problems when presenting large amounts of information on a 2D screen. So the hope was that this is where VR can be more effective and efficient, as it allows for larger view and more intuitive interactions with a virtual world. So the system was developed. It uses a back-end front-end architecture, and the choice for creating a back-end was made mainly because of it allows for preparing the data before creating the visualization itself to the user, present that to the user. So it allows to split the work between creating the visualization on one hand and sorting and retrieving the data on the other. So with this approach, generating of the visualization itself takes less time, and it avoids possible issues with lag when you retrieve it directly from GitHub. The system is built with Node.js as the ground layer, where Mongoose communicates with the database from MongoDB database, and Express.js was used for routing requests and presenting a web page to the user, where the user can enter a repository URL for the repository he or she wishes to visualize. So the system then retrieves the repository and the required information and puts this in the database. Now, the front end used was with Unreal Engine 4 with an integrated SQLite database. Unreal then retrieves the information from the backend and stores this in an in-memory database for easy access and speed. So on the right there, you see the final form of the visualization that was made. It was created in a circular fashion to utilize the 3 dimensions and the 6 degrees of freedom that virtual reality provides. The visualization was created with inspiration from the mantra by Schneiderman, overview first, zoom and filter, and details on demand. However, it does not include zoom, as it's a bit uncertain how well that works in VR at the time. However, you can still move around in the world, which is almost like a zoom. The filter and details are then presented with this hand menu on the left. So these objects, as you can see, are highlighted or interacted with. The data they link with is displayed on the wide screen behind the hand. So the objects were chosen because they utilize existing conceptual models from other systems. For example, the calendar represents the date of a commit made, which is touched over on the actual visualization. And the calendar icon is from, for example, many mobile applications use this for their main icon. So the research question was defined as the following: can a visualization of a directed acyclic graph in virtual reality be similar to or better than a visualization of a directed acyclic graph in 2D? There's a problem with this research question, and that's I'm kind of comparing a 2D system with a virtual reality system, which isn't the best. However, I was found that the usability metrics of the effectiveness and efficiency could be used as proxies to compare them. So effectiveness is used to see how good a product is at doing what it's supposed to do. And efficiency is how good a product is at helping a user carrying out their task. Now these are generic enough and at the same time specific enough that it works in both VR and 2D. So from these, the hypothesis was derived. If it was found that there was no difference between the two systems, then it would mean that the VR system had at least the same quality as the 3D system. And by answering these two hypotheses, it would create a baseline for further study of the record-basically graphed in VR. So they don't have to do as I do by comparing to that 2D system. So the approach chosen here was the quantitative approach because effectiveness and efficiency are both defined as numeric values in the ISO standard. These are commonly used in usability studies when evaluating a product. Efficiency is measured as how much time a user spent on different activities, and effectiveness is if the user found the correct answer. In a usability study, the protocol think aloud is often used, making the user say out loud what he or she is thinking. The problem in using this in this study is that the participant would have to both think about speaking out loud and actually performing the activity. So to avoid this, I added an interview at the end instead as a replacement. Also, the embedded design was therefore used as it allows for collecting both quantitative data and qualitative data on at the same time with a heavier weight on the quantitative in this case. Also, a questionnaire was used which was specialized for VR use. And only 3 parts of this was used, consisting of questions for functionality, consistency, and overall system usability. Rest was not used for various reasons, for example, not being in the focus of the thesis or not being comparable with 2D as it had to be. The questionnaire results was used to compare with the results of effectiveness and efficiency. And additionally, 2 Likert scale questions added for participants to express how they themselves felt in regards to efficiency and effectiveness. Great. So 5 tasks was created with varying difficulties. The 2 first was made to ease a participant into the system, and then turning the difficulty up to find specific commits and data. Also, the 2 subject design was used to avoid the participants learning in one setting, for example, the VR, and then applying this knowledge in the 2D. So a total of 24 participants was used, 12 for the 2D system and 12 for the VR system. So the first measurement for effectiveness was the percentage of users successfully completing the different tasks. The results vary between plus minus 16%, which is 1 to 2 users, with the exception of the last activity. This is where the VR group outperforms the 2D group with 5 participants. This was also the most difficult one. It entailed finding the second branch coming from the master, and finding a parent coming ID for this one. The second results for effectiveness was the percentage of goals achieved. this displays the same results as the previous. There's no large difference between two groups. Also, the two-tailed t-test confirmed this with a p-value of 0.69. The first measurement for efficiency was time to complete a task. This is the most important result, I believe, in my whole thesis. It took overall longer for the VR group to perform the tasks, with the exception of activity 2, where the participants had to find a merged commit. The t-test showed that only a statistically significant difference in time spent for the last 3 activities, meaning that the VR group did use significantly longer on these tasks. These 3 activities, as I mentioned earlier, are the most important ones, as they involve finding the correct commit and the correct data, which is kind of the main point of the whole visualization. The second efficiency measure was to time task completed per unit of time. Now, this only takes into consideration the correct answer and the expected time. And it was found that there's no large difference between the groups, only about 2 seconds difference for each task between the groups. However, it's a poor estimate, as the standard error is quite high. The last one for efficiency is overall relative efficiency for the different tasks, showing similar time difference between the groups. Again, the exception is activity 5, which is not surprising, as there was only one in the 2D group who got it correct. The remaining percentages here, which is not colored in, is the time spent wasted finding, or time wasted finding the wrong answer. So, conclusion, yes. So for effectiveness, there's no significant difference between 2 systems. While for efficiency, there was a difference between the 2 systems for the last 3 activities. The main purpose of the visualization is to interact and identify information. And again, that's what these 3 last questions for their activities was about. So therefore, I concluded that there is a difference for efficiency. So can a directed acyclic graph in VR be better than a directed acyclic graph in 2D? Well, most likely. The development time for the VR system was around 3 months, while Source 3 and other visualization software have had years of iterative design and improvements. And these results show that the VR still has a lot of potential. Yes. I still have 4 minutes. So this is demo. I hope it's not too dark. So here the user is teleporting over to the visualization, and then scrolling. The scroll functionality was implemented on the controller. In this visualization, there's a total of 2,300 commits plus connections. As you can see, when interacting with the objects on the menu hand, the text appears on data appears on the screen. Also, the commits are highlighted when touched, so you know which ones are on. That's it for me.
Yes.